what I had planned to get to. We did not in first hour. So it may kind of change the plan of what I had. All that will do is affect how many days we have to review for the final in class. So if we don't get as far as we need to, then we'll just push the test back, and that will just limit us to less days to review for the final. But some of you will be exempt, and that won't affect you. For those of you that are not exempt, just means you're going to have to do a little bit more on your own as you're studying for that final. Okay, we are going to review really quickly the 4 theorems that we learned last class period. If you did not start a theorem sheet, and that is helpful for you, you would like to have all of your things written in one location to go back and study with, you could do that right now and copy these down, and then we're going to add more to it today. Or you can just look at your notes, whatever's easier. So remember, the first theorem we learned last class was if the radius intersects a tangent line, what does it always form at the point of tangency? A right angle. The next thing we talked about was if you have 2 tangents that come from the same exterior point, what will be true about those 2 tangents? They're congruent. The third theorem that we learned was if you have 2 congruent angles in the same circle, then the arcs that they form will be congruent and the chords that they form will be congruent. And it didn't matter what order. If they gave you the angles, you knew those 2 things were congruent. If they gave you the arcs, you knew the angles and the chords were congruent. If they gave you the chords, you knew the arcs and angles were congruent. And then the last one. If any part of the diameter, it could be the radius, it could be the whole diameter, if that was perpendicular to the chord, then what did it do to the chord? Bisected it, and what did it do to the arc? Bisected it. So if any part of your diameter is perpendicular to a chord, it's going to bisect the chord and bisect the arc. And those were our 4 kind of rules, theorems, whatever you want to call them, that we learned in the first 2 sections. Okay? I'm going to do 12.3 a little bit different than what we normally do. I'm going to go ahead and list the 3 theorems and rules that we're going to learn today on the board first, and then we'll work some problems. So there's 3 things we're going to talk about today in 12.3. The first one, and I'm going to number this number 5. If you're making a theorem sheet, it's your 5th theorem that you're going to need to know. And it is about arc length. So we're going to talk about how do I find the length of an arc. There's a difference between the measure of an arc and the length of an arc. And every year that becomes an issue. So make sure that you read your directions carefully. What did we learn last class period about the measure of the arc if the measure of the central angle is 30 degrees? What's the measure of this arc? 30 degrees. Okay? Arcs are measured in degrees. That's their measure. The length of an arc does not mean the measure of the arc. The length of the arc means if you were to take that section that's an arc, flatten it out, and wanted to know the distance in inches, feet, miles, whatever linear unit, if you wanted to know the distance it would take to get from point A to point B. So if you were walking along that edge, how far would you walk? So it's the linear distance, not the angular measure. Are you with me? So arc measure is measured in angle degrees. Arc length is measured in things like inches, feet, centimeters. So if I wanted to find this much of my circle, first of all, what do we call the distance around the circle? Circumference. So if I wanted to find this much of the circle, what would I need to do to figure out how much of the circumference I have? Think about it. What could we do to figure out how much of the circle this is? If I know that I'm looking at the whole circumference, how could I find how much of that I need? Take 360 and divide it by, I think you mean it the other way around, 30 divided by 360. Exactly. What we need to know is what fraction of the circle do we have? How much of it do we have? Do we have a third, a fourth, a fifth, 6/7? How much of the circle? So this formula that you're going to learn right now to find arc length is just simply a fraction of the circle's circumference. And to find that fraction, you're just going to take the measure of the angle or the arc. I'm going to put arc because that's what most books put, but the arc is the same as the angle. You take the measure of the arc, like Sean said, and divide it by the total degrees in a circle. So if it's 30 degrees, it'd be 30 out of 360 would tell me how much of the circle I have, and then I would multiply that by the circumference. What's the formula for circumference? Thank you, Sean. 2 pi r. So this is your first theorem, first rule, first formula that you're going to have to know in order to work the problems today. So to find the length of an arc, you just figure out what fraction of the circle do you have and multiply it by its circumference. It is just a fraction of the circumference. Does that make sense? Okay, questions so far? All right, second one for today. Same idea, but now we're going to talk about what is a sector. And we're going to find the area of a sector. When I think of sector, I think of a piece of pizza. A sector is a part of your entire circle. Okay, it's a slice of the pie or a piece of the pizza. Sector is just a fraction of that circle. So if arc length is a fraction of the circumference, what would area of a sector be? A fraction of the area of the circle. And to find that fraction, we would do it the exact same way. We would take the measure of the arc, whatever that is, and divide it by 360. So measure of the arc over 360 times the area of the circle. It's a fraction of the area. What's the formula for area of a circle? Pi r squared. Look at these two formulas. They are super easy to confuse. Would you agree that they are very closely the same formula? One is 2 pi r, one is pi r squared, so you want to be really careful. If you're finding the arc length, it's a fraction of the circumference. If you're finding the area of the sector, it's a fraction of the area. Okay, but otherwise they're found the same exact way. You need the radius, and you need to know what is the measure of this arc, which is the same as the measure of this angle. And the last thing that's in section 12.3, so number 7 on our rules or theorems, is they're going to ask you to find the area of what's called a segment. Area of a segment. So raise your hand if you only like, or if you are the person who, when you eat your pizza, you do not eat the crust. Crust is not your thing. We all like it all right. So when you're dealing with a segment is basically the crust. So when you look at your picture, this is what they call a segment. A segment is the part of the sector that is not including this shape. What is this shape? A triangle. So how do you think we could find the area of the crust or the area of the segment? Very good, Sean. The area of the sector minus the area of the triangle. And that's the third thing for today. And that is all of 12.3. 12.3 is basically find the arc length, find the area of a sector, which is the whole piece of pizza, or find the area of the segment, which is like the crust. You're going to find the area of the whole sector, this formula, and take away the area of the triangle, which you've done previously throughout the whole course. Questions so far? Okay, we're going to jump in and work some problems. See how we do. So here's in your notes, if you'll jump straight to this slide, which should be the bottom of the first page. Bottom of the first page. Everybody see over to the right? Area of a sector. There's your formula. Area of a sector, vocabulary. We have a vocab test coming up, and these vocab words are not easy. When you read these today, they're kind of tricky. So, sector of a circle is the region bounded by 2 radii and their intercepted arc. So, if you think in your mind, 2 radii and the arc that they form, the region inside of there. That's the definition for sector. Okay, so think it's like a piece of pizza. Here's the formula. The only difference between what I wrote on the board, Elijah, you with me? The only difference with what I wrote on the board and what's up here is they didn't put measure of the arc, they put little m degree, and then in the picture they put that right by the arc. It's the measure of the arc. So don't let that confuse you in your notes, and you may want to change that if it does. Okay, and just remember the measure of the arc is the same as the measure of that central angle. When you name a sector, it's going to be the same way you would name the segment, except for the word. So be really careful. To name a sector, you cannot just put ACB, because that could mean segment, sector, or triangle. You have to put the word in front of it. Sector, ACB, segment, ACB, or a triangle symbol if you're talking about the triangle. All right, let's look at a problem. Here's the first one. Find the area of each sector. Give your answers in terms of pi and rounded to the nearest hundredth. So 2 answers. Watch your directions on your homework. We're looking at sector HGJ. First of all, there's 2 sectors that are HGJ. So here's what they'll do, what they expect you to know. If they name a sector, you go from H to G to J and draw that sector the shortest way possible. If they mean the other sector, then they won't name it sector HGJ. They'll say find the area of the shaded region, and they'll shade the other part of the circle. Okay? So usually when they name a sector, they're talking about the smaller sector, not the bigger sector. And otherwise, they'll shade it if they mean the bigger one. All right, so you and your partner, go ahead, plug it into the formula for area of a sector. See if you can find the answer in terms of pi and rounded. And rounded. As you're trying to get your 2 answers, I want to remind you, if it says in terms of pi, you should not have decimals that are rounded. You should not have decimals that are repeating. You need to change those back to fractions if they are not exact decimals. Now, when I say that, you can have 1.5. That's okay. But you can't have 1.45632. You have to go ahead and change it back to a fraction. So if it says in terms of pi, the whole point is to leave your answer exact. So don't round the number part either. In this case, you should have had 131 over 360 times pi times, what was the radius? 12 squared. In terms of pi means plug all of this in and leave it exact. So when you type that in, you should have got what? 52.4 pi. And again, it's okay to put 52.4 because it's exact. But if it had been 0.4353535, I would expect you to take that and change it back to a fraction. You could also put 52 and 2/5, or yeah, either way. Questions? Units. What are our units? We're finding the area. So what should the units be? Meters squared. And then you're going to round that to the nearest hundredth because the directions asked for both answers. Watch your directions. So what do you get to the nearest hundredth? 164.62 meters squared. Questions on area of a sector? Pretty easy? Okay, you have to know the formula. As long as you know the formula, you'll be okay. We're going to jump to, I'm going to skip this example. It's the same exact thing. Let's look at this next one. You and your partner go ahead and answer example 2. Okay, we're going to check it. It's okay if you didn't get finished, but look up here. First of all, think about a windshield wiper blade. When you look at that blade on the windshield of your car, it's going to sit there and go like this, right? Back and forth. So here's my windshield wiper blade. What is the angle that it is making as it wipes the window? 122 degrees. They tell me the blade is 18 inches long. What is that giving me about my circle? The radius. This is 18 inches. If this windshield wiper went all the way around in a circle, that would be the radius of our circle. So we're looking for the to the nearest square inch. What does that mean? Whole number. The area covered by the blade. And so they're not actually saying find the area of a sector, but that's what they're saying. Find the area of that sector. So you should have done measure of the arc over 360 times pi r squared. What's the measure of the arc? 122 over 360 times pi. What was the radius? 18, and square it. In this one, since it says to the nearest square inch, you didn't have to leave it in terms of pi. Plug it all in. What did you get to the nearest square inch? 345 inches squared. Missed my 5 there. 345 inches squared. Questions on area of a sector? Okay, I want to emphasize one more time, the only difference between area of a sector and arc length when it comes to the formula is just you're changing from area formula to circumference, right? So I want you to try some of the, we're going to skip segment for a minute, go on to the arc length problems. So we're going to skip ahead, find arc length in your notes. And here is arc length. Definition, before you get to the examples, again, because remember vocab, this could be a little bit tricky. Arc length is not going to say the amount you walk around the circle. It's going to say the distance along the arc measured in linear units, meaning not angular, not the measure, but the length measured in things like inches, feet, centimeters. So when I look here to find the arc length, I'm just doing the measure of the arc over 360 times circumference 2 pi r. Okay, so go ahead, you and your partner, and see if you can answer the next one at least. If you have enough time, do the next two. I'm only going to go over this one, but then I'll show you the answer to the second one if you got that far. So how did I know which direction to go when it said FG? Shortest. Remember last class period we talked about 2 letters means minor arc, 3 letters means major arc. So FG arc meant the shortest distance from F to G. If they had wanted you to go the longer direction, they would have given you a middle letter between F and G. So formula is measure of the arc over 360. This time, since it's arc length, we do the circumference, which is 2 pi r. Measure of the arc should have been 134 degrees over 360 times 2 times pi times the radius, which was 8. In terms of pi, you should not be rounding anything. So when you get that decimal, was it 5.9595, something like that? You need to change that back to a fraction. Don't round if it's supposed to be in terms of pi. That's the whole point, is to not round. So what is that as a fraction in terms of pi? Very good. 5 and 43/45. So 5 and 43/45 pi units, just centimeters, right? We're not finding area, we're finding the length of the arc, so it should not be squared. Okay, and then if we round it, what did you get to the nearest hundredth? 18.71 centimeters. Questions on arc length? It's not, because it's the length of the arc, not the area of the shape. So be really careful. This chapter, once again, is going to be terrible for little bitty errors with units. So watch. Everybody listen very carefully. Measure of an arc, measure of an angle. What are the units? Measure of an arc, measure of an angle, what are the units? Come on, guys. Measure of an angle was way back last semester. We've been doing it all year long. Degrees, okay? Measure of an arc, measure of an angle is in degrees. Arc length, squared or not squared? Not squared, and it's not degrees. It's units, centimeters, inches, feet. It's the linear distance. Area of a sector is going to be units squared because it's area. So watch for the words. Are you finding the area, the space inside, or are you just finding the distance? Just distance is just units. Okay, last thing in 12.3, which is probably the hardest part, again, it's not hard, but it's just harder, is the area of the segment. Because you have to find the area of the sector and subtract away the area of the triangle. So if you'll flip back in your notes, that would be here. And so notice they're showing you that the segment is the crust of your pizza, if you think about it like this. So you have to find the area of the whole sector and subtract away the area of the orange triangle, and that's going to leave you with the area of the green segment. Watch the words. Segment versus sector. I said that first period and they started their homework and I had some students finding the area of the segment instead of the area of the sector. So watch the directions. Okay. Vocabulary. The segment is the region bounded by an arc and a chord. So if you get confused on the vocab test, think about a picture. Chord and arc. They make a segment. Okay? Two radii and an arc make a sector. Okay. So we're going to do the easier problem first. Skip this one. Go to the next one. It's easier. That's this one. We want to find the area of sector RST. Notice how they named it. The same way you would name a segment, the only difference is they use the word sector. So you really have to watch those two S words that you don't confuse them. So find the area of segment RST. The first step will be to find the area of sector RST. And then what are we going to do once we find the area of the sector? Subtract the area of the triangle. Okay, so the big sector minus the triangle. So again, how do we find the area of a sector? Very good. So the measure of the arc over 360 times pi r squared. All right, look at your picture. What's the measure of the arc if we're looking at sector RST? 90. Remember, the arc and the angle are the same. So 90 over 360 times pi. What's the radius in the picture? 4 squared. Now, I'm going to warn you to try to leave your answers exact before you round them, because on the test, I may ask for your answer exact, not rounded. So let's try to leave this in terms of pi here. What's 90 over 360? What's 90 over 360? 0.25, which is a fourth. What's 4 squared? 16. What is a fourth of 16? 4. So you should end up with 4 pi here. Everybody okay with that part? All right, this one's easier because the triangle is what kind of triangle in the picture? A right triangle. What's the formula for any triangle? For area? 1/2 base times height. Okay, but if it's a right triangle, what's the base and the height on a right triangle? They're the legs. In this case, the two legs are actually going to be what? The radius of the circle. And so what is the radius of the circle? 4. So that means this other leg is also 4. So for this right triangle, it becomes easier because your base and your height are the radii of your circle, and they are both 4. And you can just do 1/2 4 times 4. Questions here for the right triangle? So we have 1/2 4 times 4. What's half of 4 times 4? Half of 16, which is 8. Okay, I want you to listen carefully before you move on. If I asked you for you to leave your answer exact, Could you subtract the 4 pi minus the 8? No. This would be your answer. You're finding the area, so what would be your units? Meters squared. So on the test, I may ask you to leave your answer exact. On this question, they said to round it. So go ahead, type it in. What's 4 pi minus 8 to the nearest hundredth? I heard 4.57 meters squared. Somebody agree with Sean? Yes? Okay. Questions on area of a segment. Okay, again, watch your words. Sector is the whole piece. Segment is just the part of it. Kind of like segment of a line is a part of a line. All right, what's going to be different? Let's go back and look at this harder one. Why is this one harder? It's not a right triangle, so when I look at that triangle, are the two legs the base and the height? No. So when I look at this triangle, what do I know? What kind of triangle is it? It's isosceles, because every triangle you're going to see inside that circle here is going to end up being isosceles. They're both the radii of the circle. So if this is 9, this is 9. So I'm going to draw it up here. This is 120, 9, and 9. What's the base and what's the height, or how do we find the base and the height? What are we going to have to do here to find the area of that triangle? Okay, we need to split it into two right triangles by drawing in our height. When we draw in our height here from our vertex straight down, this becomes the height, this becomes the base, right? So what kind of right triangle does that create? 30, 60, 90. Does everybody see that we split that 120 and this is now 60 and this is now 30? And so now this brings back your 30, 60, 90, 45, 45, 90 triangles depending on what that angle measure is. So we're going to have to find our height and find our base. So help me out for 30, 60, 90. What's always across from the 30? L. What is always across from the 60, this little piece? L square roots of 3. Then what's going to be across from the 90? 2L. So in this chapter, and what we skipped in the warm-up at the front of your notes was review of 30, 60, 90 triangles. You're going to have to know how to do those. If 9 is equal to 2L, what is L equal to? 4.5. Divide 9 by 2, you get 4.5. So what does that make the height of the triangle? 4.5. So now let's look at the base. If L is 4.5, what is this part of the base? 4.5 square roots of 3. What is this part of the base? 4.5 square roots of 3. So what is the whole base? 9 square roots of 3. Questions on how I found the base or the height of the triangle? Okay, so at this point, we should be able to find the area of the segment. We need to find the area of the sector and subtract away the area of the triangle. Let's go ahead and finish the area of the triangle since that's where we started. 1/2 of base times height. So what's the base again? What's the height? Okay, and again, you might be asked to leave your answers exact on the test. So what is 1/2 of 9 times 4.5, leaving it in square roots of 3? Calculators, calculate it up. It's 1/2 of 9 times 4.5. Come on, guys. 0.5 times 9 times 4.5. Thank you. 20.25 square roots of 3. Is that what you got? 4. Did you do 1/2 of that? Okay, and then you've got to do 1/2 of that. Everybody with me? 20.25 square roots of 3? I'm a little worried. I don't see a lot of people writing things down or typing things in their calculator. All right, area of a sector. Formula, how do we find it? All right. What's the measure of the arc? Let's go with Ethan. So when you look at the picture, what is the measure of the arc that we're looking at? 120. So remember, we're looking at this segment here, and we're trying to find the area of that segment. So the arc that corresponds to it is 120 degrees divided by 360 times pi times, what's the radius, Yesenia? 9, and we're going to square it. All right, what is 120 over 360? 1/3 times 81. What's a third of 81? 27. So let's leave this in terms of pi. I get 27 pi minus 20.25 squared roots of 3. If the direction said exact answers only, no rounding, this would be your answer. What would be your units? Centimeters squared. But this direction says to round to the nearest hundredth, so go ahead, type it in, and round it and tell me what you get. I heard 49.75. Somebody agree with Martin? Yes? Centimeters squared. Okay, that's arc length, that's area of a sector, and that is area of a segment. Questions on any of those three concepts for this section? Please ask if you do before we move on. All right, I want everybody to stand up, wake up. Do whatever you need to do before we move on to 12.4. Pinch your neighbor, hug your neighbor. High five your neighbor. This one is not stapled. Here's a stapler if you want to staple it. Yesenia, that's not going to help you wake up, girl. Stand up, jump around, do some jumping jacks, push-ups. Thumb wrestle your partner. Ah, JP. It is back there at the back. You can go stick it in there. Okay. Everybody back to your seats. 12.4. All right, gentlemen. Okay, again, we're going to skip the warm-up and just move on to 12.4. I'm going to erase this side of the board, which was what we learned last class period. I'm going to leave up there the three things from this class period, and we're going to add to it the stuff for 12.4. So if you're making a theorem sheet, you can add these new ones. I'm going to go through again and try to emphasize the key theorems before we actually work the problems. So the first thing today is we're going to talk about what is an inscribed angle. We have learned one kind of angle so far. What is the only kind of angle we've talked about so far? Central angle. And we learned that the central angle is exactly the same measure as the arc, right? But only if it's the central angle. So the second kind of angle we're going to learn today is the inscribed angle. Oops, let me go back. An inscribed angle is going to have its vertex on the circle. So angle ABD would be an inscribed angle. its measure is not going to equal the measure of the arc, but it does have a relationship with the arc, and so that's what we're going to learn. But first of all, vocab, inscribed angles are angles whose vertex are on the circle. The other key thing that's going to be important is for it to be actually classified inscribed, it has to have its sides being chords of the circle. So where that's going to come into play is if they give you a picture like this, even though the vertex is on the circle, this angle is not called an inscribed angle because it has a chord and a tangent. So it's not called an inscribed angle. It's only inscribed if it's made up of two chords or parts of a secant, which would be chords, and its vertex is on the circle. Okay? So this is not an inscribed angle. The intercepted arc is the arc that the angle makes. So when you look at this picture, what is our intercepted arc? AD. So this would be our intercepted arc, AD. Subtends, you're going to read that in directions and in problems, and that's confusing if you don't understand what the word subtends means. So here's what it says. A chord or arc subtends an angle if its endpoints lie on the sides of the angle. Okay, so here's what that means. If you have an angle anywhere, can be central or not, the chord or the arc subtends the angle if their endpoints are on the endpoints of the angle. So we would say this arc subtends this angle, or this chord subtends the angle. It just means that its endpoints lie on the ends of the angle. Does that make sense? Okay, that word's kind of tricky when you're reading the directions. Okay, so there's a picture of all of that. Here is your next theorem that you need to memorize or know about inscribed angles. Yesenia, are you with me? Okay, so write this down. This will be number 8 if you're making a theorem sheet. Okay, inscribed angles. Every inscribed angle, the measure of the angle will be equal to half the measure of the arc that it subtends. The measure of the inscribed angle will equal half the measure of the arc. Or another way to say that is, the measure of the arc will equal what compared to the angle? Twice the angle. So the measure of the angle is half the measure of the arc if it's inscribed. Everybody with me? If it's the central angle, they're the same. If it's an inscribed angle, it's half. Look at the board up here at the picture or look at the notes. Is this an inscribed angle? Yes. Is this an inscribed angle? Yes. Is this an inscribed angle? Okay, they're just showing you that it doesn't matter whether it goes through the center, not through the center. As long as the vertex is on the circle, it's an inscribed angle. And the rule is that the angle is always half the arc. Okay? The next thing, I'm going to again skip examples and move on to the actual theorems. Here's the next one. This is going to be really important. It's not really anything different. It's really the exact same theorem, but they're just applying it to several different angles. If you have more than one inscribed angle and they subtend the same arc, so look at this angle here. Is BAC an inscribed angle? Is BEC an inscribed angle? Okay. What arc do they both subtend? BC. So if they both have the same intercepted arc up here, then what should that mean about angle A and angle E? They are the same because they're both going to be half of BC. So this angle should equal this angle. Does that make sense? Okay. That's what this says. Okay, and then again, I'm going to skip ahead to this one. Yes, ma'am. Exactly, good. So if you look at what Emma just said, I don't have a different color. Oh, well, I'll use this one. So if you look at ACE and ABE, what arc do those two angles subtend? AE. And so that would mean that this angle and this angle would also be congruent. All right, any other questions or comments about this? Okay, look at this. This really, again, isn't anything different. It's using the same theorem about your inscribed angle. But what do you notice about this dashed line? It's the diameter, which makes this arc how much? 180. So what this theorem is saying is that if you have an inscribed angle and it subtends the semicircle, you're always going to create a right inscribed angle, okay? Because this angle will be half of this arc. So it's not really another theorem. It's still just the angle is half the arc. They're just reminding you that if that angle is formed by a semicircle, then that angle is going to be half of that, or it'll be a 90-degree angle. Is everybody okay with that? I'll add that up here as one of our theorems, but it's really not anything different, I don't think. So if this is the center, then that makes this angle right here a right angle. Okay? And the last thing I think that's in this section, I'm going to jump ahead, is this one. Is this the last theorem that you see? Is there another one after that, or is this it? Okay, so this is the last one from 12.4, and again, it's not a whole lot different than what we've been talking about, but it does apply to quadrilaterals, and this is really important, so look at your notes. If you're making a sheet, this will be number 11. Here's the deal. For a quadrilateral to be inscribed in a circle, remind me, what does inscribed mean? Inside, and every vertex actually touches the circle, right? So the only way that a quadrilateral can be inscribed in a circle is if its opposite angles are supplementary, the opposite angles. So if this is A, B, C, D, which angles have to be supplementary? AC, these two, so the measure of angle A plus the measure of angle C has to be 180. And what other two? Angle B and angle D. They do not have to be congruent to each other. They don't have to be 90 degrees. They could be, but they just have to be supplementary. So think about some quadrilaterals that you can guarantee would be inscribed in a circle. What kind of quadrilaterals definitely would be opposite angles supplementary? Squares, what else? Rectangles. There's going to be a question on your homework that's going to ask you, so think about all quadrilaterals. But for sure, it's pretty easy to see squares and rectangles because 90 and 90 and 90 and 90 are supplementary. Okay, let's work some examples that are the harder ones on the notes that use these ideas. But that is 12.4. That's all there is to it. So I'm going to skip some of the easy ones maybe and look at some of the harder ones. This one's not very hard. Let's skip it. It's pretty easy. Let's look at this one. It's not hard, but it just makes you go backwards. So look at this one. Find each measure. Measure of arc SP. First of all, how do I know which arc it's talking about? Shortest distance, 2 letters. So what did we say the relationship is between the arc and its angle if it's inscribed? The angle is half the arc, or the arc is twice the angle. So if I'm looking for the arc, it needs to be 2 times 27. So what is the measure of the arc? 54 what? Degrees. So remember, we're back to measures of arcs and angles, so those are going to be in degrees. So pretty easy there. All right, I'm going to come back to this one at the very end and see if I can get someone who can get that one right. Look at this problem. So skip to here. Skip to here, example 3A. What would we know here about the angle Z? It's a right angle because what do we know about WY line segment? It's the diameter. So what does that make this arc? 180. And if this is 180, then the angle that's inscribed here has to be half of 180, which is 90. So what would we do to find the measure of A? Say it again. What would we do to find A? 5A plus 20 equals 90. And I know you can do that math. Okay, so again, our rule is the angle is always half the arc. So if I look at this picture, do you notice that this is the diameter going through the center X? So if this is the diameter, that splits it into two semicircles. A semicircle is 180 degrees, which means the angle that is formed subtends 180 degrees, so it has to be half of 180, which is 90 degrees. Does that make sense? Okay, and that's this, also this theorem up here on the board, that if your angle is formed by the diameter, it's going to always be a right angle. Any questions there? Okay, I'm going to skip that then and not go all the way through it. Look at this picture. Which theorem up on the board, 8, 9, 10, or 11, is this one going to require us to use? 9. Notice the two angles that it's pointing at are angles J and K. And what is the arc that they both intercept? LM. So this angle intercepts this arc LM, and this angle intercepts this arc LM. So what does that mean about those two angles? They're equal. They're both going to be half of that arc. So what would we write down on our paper to solve? (5b minus 7 equals 3b. Stop me right now if you don't understand why those two angles are equal. I also want to warn you that you might be setting expressions equal that turn out to be quadratic, and that then you have to solve either by factoring or using a quadratic formula. Okay, at this point you should be able to solve for b and then go back and plug it in to find angle LJM. So I'm not going to work the math there. Questions on this one? Okay, Jackson, are you good? Okay. All right, look at this one. Which theorem up here on the board is this one going to require us to use? 11. We have a quadrilateral in a circle. So what would I do to try to figure out the angle measures of this entire quadrilateral? Where would I start? Okay, I'm hearing Christian whisper over there. We know angle J and angle G are what? Supplementary. Be careful that you don't set them equal. They're supplementary. So you could say 6b plus 20 plus 3b plus 25 equals 180. Let's go ahead and work this problem so I can make sure you can find all the angles. What would I get when I combine like terms here? 9b plus 45 equals 180. What would I do next? Subtract the 45. So 9b equals 135. Divide by 9, and what do you get for b? Say it again. 15. Okay, I went pretty fast there. Did I lose anybody? Okay, if b is 15, we need to go and we need to find all these angles. So let's start with angle J. Make sure you use correct notation. Measure of angle J equals 6 times 15 plus 20. What is 6 times 15 plus 20? What is it? 110? Okay. 110 degrees. I could substitute in 15 up here for angle G, or what do I already know about angle G and J? They're supplementary. So what does angle G have to be so that this becomes supplementary to 110? 70 degrees. So that's probably easier, but you could plug it in just to check and make sure you didn't make a mistake. Okay, let's find angle K. The measure of angle K should equal 10 times 15 minus 69. What does that give us? 81? Okay. And again, I don't know what angle H is by expressions, but what do I know about K and H? They're supplementary. So what's the measure of angle H? 99 degrees. Questions on this example? Okay, was this the last example in the notes? Yes? Okay, so here's what I'm going to do. There's one example that we skipped, right? I'm going to blow it up here on the board, and I'm going to see who can find the answer first. And whoever finds the answer and can explain it correctly, just getting the answer is not good enough. You have to be able to explain how you got the answer correctly will get a homework pass. Okay? First person who can get it correct and explain, and it's the one we skipped that's crazy looking, but it's really hard to read on your paper perfectly. So hold on, and I'm going to show it up here on the board. Hold on one second. Oops, that's not what I wanted to do. Hold on one second, one more time. All right, this is the one. So you guys see it in your notes? What does the question ask you to find? The measure of angle DFA. So you are looking for DFA, and you have to tell me when you think you have the answer. Don't say it out loud. Write it down on your paper. I'll come around. I'll check it. And if you're correct, then you have to be able to explain it to earn the math card.